game is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is to continue working on our beautiful, beautiful waveform display. And the first effect that we are completing using the new library we are developing for JSFX, for developing real-time audio processors in REAPER. And just look at this embedded on the track control, on the mixer control panel. This is beautiful. I love it. So, next steps. We are going to pick up where we left off last Tuesday. There is a notion of detecting that the plugin is not showing. Or I guess it is always showing because it's on the track control panel, on the mixer control panel. Damn it, on the mixer control panel, not on the track control panel. It's on the mixer control panel. So it's always displaying, but now I can turn it off. So now it's not displaying anywhere and the plugin knows that it's not showing up. So it stops collecting samples and that saves some CPU. It turns out that even with the collection of samples and display showing up and everything, we are registering 0% CPU, at least on my computer. So I cannot really prove that this is the case, but it is. So if our plugin was consuming a lot of CPU, then when it's not showing up, it would stop consuming that CPU. Because it's not doing any work when it's not showing. Great, so we have this concept already. But what's missing is the concept of detecting that we are bypassed. Right, because when the plugin is bypassed, the user interface is still showing, or it may still be showing. And if it is, then you don't want to display the waveform because audio is not coming through and we don't have samples to show. And the problem that we are going to solve to begin with in this coding session is the problem of when we are getting back from bypass, we should erase what was there on the buffer because we don't want to display old stale data as we currently are. So that's the main task, or that's the first task we are going to tackle today. But also, let's just celebrate the fact that this is taking 0% CPU, which is great. It is awesome news. In fact, perhaps if I draw two of them, then this will take one. Yeah, there you go. If I draw two waveforms, and this is a stereo channel, a stereo track in REAPER, but really the audio that is coming through is mono. So it has two channels because every track in REAPER will have two channels, at least. And my microphone is mono, so the same audio is going through both channels, but the logic to collect samples and display samples doesn't know that, so it's doing double the work. And now we are getting 0.1% CPU, and if I go to requeue, then you see this number dropping to 0, because we are not doing any extra work. The plugin doesn't take any CPU while it's not showing, as it should, right? Makes sense for that to be this way. And that's another issue that we just saw, actually. I went to requeue, so we're not collecting samples, and that means that when we get back to the waveform display, we should have erased the old stale waveform that was there. And this is, I think, a nice touch. I think that this is something that people will like. And it's something that many plugins don't do. So I think it's nice that we do, or try to do it right. Okay, let's get into the code and see how we can do that. The first step is actually nothing to do with the waveform display itself. It has to do with the logic we use to detect whether we are running or not. And I do want to test something out, and I do have a test plugin here, and it doesn't seem to be doing anything interesting. So I do want to test, and this is just more for curiosity's sake. I want to test if the init block, and for that matter, the slider block, if these blocks of code will run when we bypass and then come back. So let's see under what circumstances init and slider are going to run. And if I remember correctly, then the presence of a serialized block affects that. And we always want to have a serialized block for other reasons. It has to do with versioning. So I will have an empty serialized block, or not empty, I guess just a no-op here on the serialized block, just for it to exist and to alter the behavior of the slider and init block. So how do we know if something has run in JSFX? Well, there are plenty of ways, but this is probably the most straightforward one. We can add 1 to a variable, and then on the IDE in REAPER, we can see the values of these variables, and we can know what blocks of code are running. So let's experiment with this test plugin. Oh, not this one. That one. And here's what I'm talking about. So for whatever reason, the init and slider blocks have already run twice. It does not make a lot of sense to me. They probably should have run only once, but still they ran twice. Okay, so if I start playback, then I think that they should run once more, and they do. Oh, and when I stop, they run once more again. Hang on. If I start, they run, and then when I stop, they run again. Go figure. JSFX can be unpredictable, at least for me. I couldn't predict that. Surprising behavior. Whatever. Now let's get to what I wanted to test. If I bypass and come back, it does not rerun the init and slider blocks. Great. Even if it did, I wouldn't rely on that, because there are ways for you to turn off this property of rerunning the init block. You can set a variable that will change that behavior. So I wouldn't want to rely on that, but it seems like we can't. We cannot rely on the init block to tell whether we just came back from being bypassed. So we already have in place something that will detect that we are starting bypass. And that's why we no longer show the waveform. But we need to extend that to know. So yeah, I guess in general, the goal is there are two threads of execution. There is the audio thread, receiving samples, and then there is the user interface thread, drawing this. And in both cases, in both threads, we want to be able to tell if they're running, and we want to be able to tell that from the other thread's perspective, right? So from the user interface thread, I want to be able to ask if I am being bypassed or not. And conversely, from the audio thread, I want to be able to tell whether the user interface is showing up or not. And it does not really make sense for me to ask about whether the audio thread is running from the audio thread, because if it's not running, how could it ask that question, right? So we are only concerned about the other thread. So that's concern number one. And we already have implemented that. We are going to go over how that works just because I think it will be necessary, but we have already implemented that. But then There is the second concern. The second concern is from the audio thread, I want to be able to tell that I have been bypassed and I'm just waking up so that I can do some cleaning up. This is, I guess, similar to the intent of the init block or perhaps the slider block, but it has nothing to do with the playback starting and stopping, and it has nothing to do with the user moving sliders around. It has to do with the user bypassing and stop bypassing, or I guess unbypassing. So from the audio thread, I want to be able to tell that I just woke up. And the same is true for the user interface thread, but I think that that code is already there. We have already implemented this. So from the user interface thread, I want to be able to tell that I was not showing, and I just started showing. So in both situations, I want to be able to tell that I just woke up from the audio thread and from the user interface thread. Oh, and look who is here. Bo is here. Hello, Bo. How's it going? How was your week last week? Because last time we talked, it was Wednesday. Or I guess you tried to talk to me and I was unavailable. Sorry about that. I will reply. I on Discord, by the way, I will reply. But I was unfortunately unavailable to do that during the past week. But this week, I'm going to get back on track with Discord and everything else. And for people who are watching this and they're like, Discord, what is Leandro talking about? Well, go to the link below in the description, the link to my website, and there you'll find a link to the Discord channel where we can talk to all of us, Bo and me, many other people who are super talented and know way more than me and help me learn stuff. So it's a great place if you're learning stuff. Just go there and hang out. All right. Yeah. Okay, well, let's get back to business here. Let's see the code that we already have for the whole detecting whether the other thread is running. Okay, we're going to revisit that. Thanks for being so understanding. You were very nice, Bo. Okay, so the implementation comes in two parts. There is this, and then there will be that. There will be that. And let's go over how this works, the high-level idea of how this works. So the two threads are going to challenge one another. And okay, there are different ways of going about this. There are different ways of implementing this. And I think that we'll need a more sophisticated way where we look at the clock, but we'll get there when we get there. Let's start by going over how this works right now. And it does work, but there are things that we would like to do that I think will be impossible with this strategy. But let's go over the current strategy. I did not come up with this. You can see this link here for, I think it was Geraint Love. Yeah, explaining how to do this. And my version is a bit more sophisticated because, yeah, it implements this idea and it is bidirectional. It goes from both threads to both threads. So let's go over how this works. Let's consider the case where we are the user interface thread and we want to know if the audio thread is running. So on the user interface thread, we challenge the audio thread. And that's what this is. This line is challenging the audio thread. It is saying, I bet that you are not running. So what this is just a variable, okay? So this is just a Boolean, so to speak. It's either going to be 0, false, or a number greater than 0, true. So this is just a Boolean variable. It just so happens that in JSFX, as well as in C and perhaps a few other languages, a variable is either true or false by being either different from 0 or 0. So Booleans are represented with numbers, and the notions of true and false are represented with numbers. So we take advantage of that, and we kind of abuse that system by saying, okay, sample thread, I guess, audio thread, I bet that you are not running. So I am subtracting 1 from your current value. And we never want this number to be negative because that would be weird. So we take the maximum between 0 and whatever this is, because if this is 0, then this will be -1, but the maximum will be 0. So we are never getting into negative numbers. So this is challenging the audio thread by saying, I bet that you are not running, and subtract 1. But then when the audio thread runs, it says, yes, I am running. And it does that by just setting a number larger than 0, a number greater than 0. That's all it has to do. And 3 is not 0, so it will be interpreted as true. In other words, we are claiming, I am the audio thread, and yes, I am running. And it could be any number here. It could be 100, it could be 1,000. What is the implication of different numbers? Well, the implication is how long it takes for the user interface thread to realize that the audio thread is not running. The smaller the number, the faster the user interface thread will realize that this is not running. And now think about how this works. Typically, both threads are running, the audio thread and the user interface thread. So this is being set to 3, and then this is being set, I guess, to 2 and perhaps to 1, but then this runs again and sets it back to 3. So we never get down to 0. And now consider the case when the audio thread is bypassed. The plugin is still open, so we still see the user interface, but the audio thread is bypassed. Then this code is not running. So this code runs 3 and then more times. So this becomes 0. And then on the user interface thread, we know that the audio thread is not running. And we can do various things like stop displaying the waveform when that's happening. So that's how that works. Then we also have the exact opposite idea, and that's the JSFX running variable. So in this case, we are the audio thread, and we want to ask if the user interface thread is running. The point of this is what I showed before. The audio thread doesn't need to be collecting samples if the samples are not being displayed. So we challenge the user interface thread by saying, I bet that you're not running. So this is a Boolean variable, just the same as this one. And this is the same kind of challenge. We never get into negative numbers, same story. And then from the user interface thread, we say, yeah, I'm alive. And when the user interface thread is running, this is setting this variable to a large number. And in this case, I did not hard code the number. I actually used a formula to compute the number. It's going to be a large number. And again, you want this number to be, I guess the trade-off is the larger the number, the longer it takes for the audio thread to realize that the user interface has been closed. So we don't want a number that is too large, because we want the audio thread to realize that the user interface thread is closed as quickly as possible. But if the number is too small, then it can be the case that the user interface thread, for whatever reason, has to skip a frame. And if it has to skip a frame, then this line will not run, so it will not answer the challenge. And then the audio thread may mistakenly think that the user interface is not running. So we don't want the number to be too small. So the trade-off is the larger the number, the less glitches, because it will never be the case that the user interface thread is running but skips a frame or two, and the audio thread thinks that the user interface has stopped. So it's not going to happen if the number is large. But if the number is large, then it takes longer for the audio thread to realize that the user interface is closed. So that's the trade-off. You want the number to be big enough for glitches not to happen, but you don't want it to be too big, so it takes too long for the audio thread to realize that the user interface thread is not running. And that's what this computation is. So we do a computation here that is a bit more complicated than just a fixed number. And what it does is it takes in account the sample rate, the number of samples in a block, because this is only running on every block on the audio thread, not on every sample. And then it also takes in account the refresh rate, which is just a variable that we set. And then it computes how many samples will there be between two consecutive frames of the user interface. How many samples of audio are there between two consecutive frames of the user interface? So that's what this does. But then we say, okay, I need a bit more leeway, because suppose that the user interface skips a frame, or 5 or 9, because your computer is struggling to do things. We don't want necessarily to say to the audio thread that the user interface has stopped. We don't want that. So if a frame or 2 or 9 are skipped, that's fine. We just multiply by 10, and then we say, okay, if 10 frames have been skipped, then the audio thread, I guess, wins the challenge, and we can say that the user interface has stopped. And I don't think that we need to change much about this. Or perhaps we will. We'll see in a moment. But then there is this other thing here. And this is a way of the user interface thread realizing that it's just waking up. So it's as simple as saying, if the user interface was not running, then set this variable to true. And that means the user interface is running, because we are running this line, okay? So if we get to this line, it's because the user interface is running. But we can ask, was it running before? And typically, yes, it was running before. But if the effect was closed and then reopened, it was not running before. And then this will be true. And then we do some things that are special for when the user interface is just loading, like erasing some buffers and whatnot. What we want is something equivalent to this for the audio thread. So we want to have a line that is similar to this, except that it is for the sample block, for the audio thread. And now with this, the audio thread will know that it was bypassed because it was not running, and it just woke up. So I think we have the infrastructure, but there is a bug. So let's take note of this bug, and I don't know where to do that. I guess I will do that on the waveform thing, because that's where we took note of this before. And the bug has to do with what happens if both the audio thread and the user interface are bypassed. I'm going to put bypassed in quotes because the audio thread is bypassed, the user interface is closed, but the intent is the same. So what happens in that case? You think that this will break things, but let's first try to use this sample reset, sample running, GFX running, and GFX reset. Let's try to use these 4 variables in the most sensible ways. Guys, I will have a separate buffer here where I have the names of the variables just to keep things organized. I don't want to be jumping up and down in code too much. Yeah, so we have a way of telling if the other thread is running and a way of telling of if ourselves have just woken up from having been bypassed. And I will commit this even though it is, I guess, 1 line. And I also removed a space. So simplest thing ever. But still, I'm going to commit this. The first thing is let's review our Waveforms plugin to see places where we would like to use these 4 variables. So this tells us that from the GFX block, if the sample block is running. What do we want to do with that? And I guess we are already doing something with that. We want to not display anything, because this means the audio has been bypassed. We should not be displaying any waveforms. And here it is. We are checking this variable already. I think that we did this last Tuesday. And then there is a big conditional here. So when you're asking something to be drawn, a waveform to be drawn, we're going to check, is the effect bypassed? If it's not, then okay. If the audio is running through the plugin, then do all the drawing. Otherwise, check what happens. This is the end of the conditional. Nothing happens. So we just skip drawing altogether if the plugin is bypassed, if it's not receiving audio. That's exactly right. Then we have this, and this is a way of telling from the audio thread if the user interface is running. And what we want is to not collect samples. And we do that here. There is something interesting about this. From one direction, from the user interface checking if the audio is bypassed, I am doing the checking on the library. But from the other direction, from the audio thread checking if the user interface is open, I am doing the checking on the effect, not on the library, but on the effect using the library. And the reason why I am doing this here is because I want to save as much work as possible. I could have an implementation of push that checks for this and then doesn't push. That would save some work. It would save the work of going to memory and fetching stuff, from computing a circular counter, from pushing into circular buffers and updating the right index, from storing more stuff into memory. It would save a lot of work. But it would still require you to check this if the user interface is running. It would require you to check that a bunch of times in a loop. It would require you to loop, which is already a somewhat expensive operation in JSFX. So this is not ideal, or I guess implementing the check in the implementation of push is not ideal. It's a lot more checks, and it requires you to loop. So doing this way is much better. And doing it this way, where we check on the library, it's not as nice. Because over here, on the user interface, we are looping, and we are asking to draw, and we are doing a bunch of computation here. We are doing a bunch of conditionals and everything to call a function that will not draw anything, because we are calling the draw function, but it will not draw anything. It will skip the drawing. So I think that we should not be checking that here. We should be checking that there. And there is a disadvantage to this approach. So the advantage is clear. It's less work. The disadvantage is that we are requiring everyone who is using the library to do this check themselves instead of us doing the check in the library. So the trade-off is this is a bit slower, but it is in a single place. So that's the trade-off. And I guess there is another thing. There is another consideration. Because this check is here, the library is forcing your hand. The library is saying, I am not drawing. I give up on drawing. And I think that's a sensible thing, but suppose that your user interface wants to display the waveform grayed out when the effect is bypassed or something like that. So perhaps you would like control over what happens. Perhaps you would check this variable and set a different color for the waveform, but you would want to draw it anyway. Yeah, so given this and the performance thing, I am willing to just check over here. But this time, we do more things on this loop. So we have to see what other things we are doing in this loop. I guess we are adding one to the channel, we are updating coordinates. Yeah, so there is nothing else that we do besides drawing the waveforms. So it makes sense for us to check this over here, then have a whole block that is skippable. And this is saving some work, all right, because it's skipping a bunch of code. But the main intent is that you get more control. Yeah, I think that this is a nice trade-off. So we do this check over here, and everyone who wants to display the waveform will have to do the checks themselves. It's just the way things will go. And over here, we don't have to check. How is your code coming along, Bo? The code that we started on Wednesday, did you have a chance of working on it more? Perhaps you did the other channel, the right channel. How did that go? How is C++ and Juice treating you? Let's commit what we have. And let's test this on the interface, because the behavior should not have changed. We just changed the way we implemented things. Oh, would you look at that? Tail is here. Hello. It's great to have you here. I'm doing fine. I hope that Bo is doing fine too. Yeah. And how are you doing, Tail? How was your week last week? All right. let's test this. Okay, so let me turn on square root, which makes more sense because the signal coming from a microphone is relatively quiet. So this is drawing, and if I bypass, it stops drawing. All right, so this is checking the running variables. Oh, good. Nice. I've been getting my feet wet on LT Spice and I guess electronics in general, and trying to understand how to run all the different kinds of simulations like AC analysis and stuff. So yeah, I'm looking forward to doing that thing that we started talking about, where you would walk me through the way that you use LT Spice and the way that you do, I guess, physical modeling. And man, it gets so deep and interesting. Electronics is a lot of fun. And I'm even thinking about just buying a couple components and doing some of the simpler circuits, like a filter. I think it would be such a simple but satisfying project to run audio from my audio interface into a breadboard and have a resistor and a capacitor and have that as a low-pass filter. That sounds like a lot of fun. And I even ran audio through a LT Spice simulation of a simple low-pass filter, and it worked. And I was like, hey, that's awesome. So I would love to learn how you do physical modeling, to learn about how you go from the model to C++ code. I mean, that would be very interesting. Okay, Bo says, issues with my MacBook, so no progress in juice. Okay. Sorry, that sucks. I'm doing C++ tutorials on my PC instead. Oh, okay. Okay. Can you run Juice on your PC? And which do you prefer? Do you prefer Visual Studio, Xcode? Or do you not have a preference because they both suck? That's the impression that some people have. They both suck. And we love doing audio processing, but we just hate everything about the tools. Some people are like that, and I guess I see their point. Anyway, so now let's look at, and I think that this is all we want to do. So we want to stop, we want to stop collecting samples when the user interface is not running, and we want to not draw when the audio is bypassed. So we used these two variables in the way that they think they should be used. Let's just check that we don't have anything else going on, anything weird going on. Yeah, okay. So we are not using the sample running anywhere in the library. We are defining it, but we are not using it. And JSFX running, there is a single occurrence in the plugin, and there should be 5 occurrences, and there are. So 5 occurrences of the variable here. There is this comment, there is this that is defining, but never using. And then this, I don't think it's used anywhere. It's just defined here on this line. And this, it's just defined there on that line. And over there, it's not used either. Okay. So now let's get to use these things. What we want to happen is when, and I don't know exactly where I want to do this, but what we want to happen is to erase the circular buffer that stores samples when we are resetting. So we may be resetting because the plugin was not showing. Like this, and we just came back. So we may be resetting because of that. And we may be resetting because we were bypassed and we just woke up, right? So under either circumstance, we want to erase everything that we had, every little line here. We want to erase this circular buffer. Now the question is, where do we want to ask for this erasing to happen? We have two options. We can do this from the audio thread, and we can do this from the user interface thread. I think that doing it from the user interface thread would be simpler, but I think that doing it from the audio thread is more correct. I'll explain all of that in a moment. Yeah, LT Spice is fun. Doing real electronics on a breadboard or whatever could be fun as well, although I do like virtual components in that you can't blow them up. Yeah, I am very nervous about, well, first of all, spending money on components, because it's not too expensive to get a kit with capacitors and resistors and perhaps even inductors, I don't know, some simple transistors. But the thing is, I don't know if I am buying the things that I would use. You know, when you get into a new hobby and you're like, yeah, I am into drawing, and then you go to the art supply store and you get 5 different kinds of pencils and whatnot, and then you end up using one. I feel the same way about electronics. I feel like if I just buy those kits and buy a lot of components, I will be just getting junk, essentially. And I am also nervous about connecting audio. I'm thinking like, do I buy some cheap audio interface just for testing stuff? Because I think there are ways you could damage the audio interface if you connect the wrong wires. You could overload, like if you turn on phantom power, you could overload the interface and blow things up, I think, internally. And I don't want to do that with my main audio interface. I was thinking maybe I will buy one of those cheap $20 audio interfaces just for testing stuff. I don't know. Yeah, I'm nervous about this because I'm not really sure I understand my way around things. For one thing, I don't really know how phantom power is transferred to through the wire. I know it's like a DC thing on both the hot and cold wires on the XLR cable, but I'm like, well, how does that even work? And what is the difference between ground and 0 volts? I have a lot to learn. That's what I'm trying to say. I have a lot to learn. There is a lot that I don't know. And blowing things up is something that makes me nervous because I don't want to lose money just because I'm learning and new to stuff. I guess it's inevitable, but still. I'm doing regular C++ tutorials on my PC in code blocks. Yeah, I checked that. I remember I said that code blocks is supported by Juice, and I am right. Yes, it is supported. I think it's like a tentative support. It's not like as mature as Xcode and Visual Studio, but it's there. I can show you that. Code blocks on Linux is definitely a thing, but on Windows it's also there. Yeah, and CLion is deprecated. Okay. So these are not deprecated. They should work relatively well. I wouldn't count on them being awesome, but maybe they are. Who knows? I need to get my basic C++ skills sorted to make any progress in Juice. Yeah, what I'm finding is that because all the infrastructure work is done by Juice, or not all, but a lot of the infrastructure work is done by Juice, turns out that you don't need to learn a lot about C++. You can get by with the basics. You can go far, not all the way there, but you can get somewhat far. If you think of just the process block function as the only place where you have code, like forget about everything else and the user interface, forget about it, you can get far with basic C++. But then if you want to do anything more interesting, like JTing from Chow Tape and whatnot. He's doing, what is it called? WDFs. I think it's Wave Digital Filters, something like that. I forget. He has a whole template library in C++ to make things faster and to do some of the work at compile time. It gets very deep into the inner workings of C++. But that's like way beyond our pay grade. Yeah. And you do need to know some C++ to be able to sort out the documentation for Juice. It is great that it exists, and Juice is better documented than iPlug2, I think. But still, you have to know C++ to navigate the documentation. All right, so how are we going to use these variables? Are we going to do that from the audio thread or from the user interface? I said that from the user interface, it would probably be simpler. And conceptually kind of makes sense. If you are going to draw the waveform, you can check if you have been just woken up and then you could erase the buffer. But I think it makes more sense to do it from here because this is the place where we write, right? We are pushing, we are writing into the circular buffer. We are changing stuff in that chunk of memory. So it makes sense for this to be responsible for erasing when necessary. Yeah, it would be something to think about, but I guess before we even do that, we need to have a way of erasing things. And we had so far, I think, 15 incarnations of the waveform display, and in a couple of them, we had a way of erasing parts of the circular buffer, but in this one, we don't have a way of erasing parts of the circular buffer. So I think we need to address that. Luckily, it is relatively straightforward to do. Oh no, I'm just thinking of the implication. It's not as straightforward as I want it to be. Okay, let's get to the implementation of the circular buffer. And I think it could be the responsibility of the circular buffer to know how to reset itself. So let's implement this function over here. So we are taking a couple steps back. Our end goal is to be able to erase the circular buffer when we are just waking up. But to do that, we will implement the ability for a circular buffer to reset itself. As I said, luckily it's not that hard because a circular buffer is just a chunk of memory. So we can just use memset to do that. So let's go ahead and do this. We have a function to create a circular buffer, to push data into the circular buffer, to get with interpolation. But let's add another one, which is, or perhaps we'll add this one up top, because it's closer in spirit to creating a circular buffer. And I'll call this one reset. So given a circular buffer, we can use memset on the circular buffer. How many elements? This many elements. What value? I guess we'll just have a 0, or perhaps we could ask for that value. For now, I'll just hardcode this 0 here. So let's refresh ourselves on what memset does. In JSFX in particular, though the implementation is the same as the C implementation. And JSFX programming, am I in the right place? I think I am. Yeah, memset. So yeah, this is the place, the address in memory that we want to start erasing. This is the value. Oh, I got it wrong. This is the value that we want to set in that place. And this is the length. So how many slots in memory do we want to set to 0? Oh, I think we lucked out. I think that this is going to work. Yeah, I was nervous saying that perhaps it's not going to be as simple as I thought, because there are plenty of functions that use memory, like memcopy, and computing FFTs also uses a chunk of memory. And in many of these, you cannot cross a certain boundary. And we do have a notion of allocating memory that is aligned, but a circular buffer does not use that. In fact, we have not used that yet. We are going to use it when we create buffers for FFTs, for instance. So we have that facility in place. We can allocate memory that is aligned, but we're not using that. But we lucked out because memset does not have this restriction. As far as I understand from reading the docs real quick here, we can cross a boundary. We don't have to align the memory for the buffers. So we can just say memset. It will work. Awesome. So this is the way we can reset a circular buffer. We'll write a test to make sure that this works. But first, yeah, that's the thing. I need more basic C++ skills. I can hack my way through some other languages, but with Juice, I'm hitting a wall. I can see why. Personally, I think that C++ is one of the most challenging languages I have worked with. But it can also be one of the most rewarding ones, so I think it pays off. So let's write a test right after... I want to be able to run these tests that get, and then I want to reset and check some new values. Yeah, I will have some preliminary tests here. So besides the circular buffers, I will also have result, as in test results. And result will be equal to that to begin with. And I will be cute and align the code. Then I will, oops, I bumped into your ears. Sorry about that. I'm using a new microphone. Do you like my new microphone? Do I sound different? Do I sound better? Do I sound worse? I was using the SM58 for the better part of my streaming career. I also use the shotgun mic that attaches to the Zoom H5, but for the most part, I use the SM58, and then now I got a Rode Procaster. I'm liking it. It looks great. I think it sounds better. I like how it's more consistent on the low end. It doesn't have so much proximity effect, so as I move around, I don't hear as many weird resonances on the low end. But that's already very subjective. So how do you like my new microphone? I think that this looks so nice that I was thinking about just having it on the shot. But then it looks like I have just a giant, you know what? It looks like a dick. So I decided not to have it on the shot. Anyway, let's call reset with the circular buffer. And then we can say result and we can effectively just do this same gets, but in this case, we expect to see a bunch of zeros in there. Okay, I don't like the way that this reads. It reads a bit awkward, but it is what it is. There is no way of having your cake and eating it too, is there? So this test should be passing. But is it passing? Circular buffer, pass. Hey, first try. Well done. I'm just curious, have you guys ever done any pure C? I have, which I guess helped when I started with C++. Personally, I have used C, I want to say about 12 years ago, 10 years ago, something like that, when I was taking introductory courses on my university. I was using C. But to be honest, it was just some university projects, and it was like introduction to programming. So very basic stuff. We started with Pascal and then we moved to C for a semester. But then for the other courses, we stopped using C. Like Java, we used Java for our data structures course. We used MATLAB for our numerical processing kind of courses. So I used C very little. I do know how to write C. I guess it's like playing chess, okay? It's like playing chess. I know the rules of the game, and if you want to learn the rules of chess, you can pick them up in like a couple hours, or if you're very smart, in I guess 1 hour. The rules of chess are relatively straightforward, but to play chess well, it takes a lifetime. And the same is true of C. I don't know the rules of C, but I know that there are 1,000 different ways to shoot yourself in the foot, and I would probably do that. I would probably shoot myself in the foot in all different ways. From security perspective, performance perspective, segmentation fault, all of those mistakes I would make. But I do know the semantics of C, and I have studied the programming language theory aspects of C++ before. So I'm not completely new to the language. I knew about templates and how they work. I knew about virtual function calls and how classes and inheritance and all of that works in C++. I knew that before we started this study group. I guess that helps a little. But yeah, I have never written any serious professional code in C or C++ yet. Yeah, the mic sounds great. Thanks. Yeah, thanks. Yeah, I spend so much time tweaking the audio effects that I run on the microphone and tweaking mic positioning and tweaking the room. And I'm way past the point of diminishing returns. But it fills my heart with joy to hear that the mic sounds great. Oh, you were just going to say that the low end is nicer. Yeah, awesome. So perhaps it was just my suggestion, but you noticed. Great. JSFX is kind of C-ish. Yeah, oh, and I guess one thing that confuses many people who are beginning in C and C++ is the whole pointers and arrays and references and whatnot. And I got those sorted out. I learned about them 12 years ago. And yeah, I have an okay grasp of what's going on when people talk about the free memory and stack and all that entails. I have a background on that. I did some coding in college for typesetting machines. Wow, that's amazing. I really, really like typography, and typesetting machines are fascinating. They're the precursors of the modern computer, so I always find that very interesting. No idea what language it was. I've done some Fortran. That I have never done. So that's another language that many people use for numerical computing, but also for historical reasons. And Fortran, I would not recognize a line of Fortran if it's slapped in the face. I don't know Fortran at all. And the bulk has been HTML and CSS. Yeah, that's a different mindset completely. HTML and CSS, they're not even really programming languages, are they? They're more like markup languages. It's in the name. And this is for styling, so it's not really programming. It's more in the design spectrum. All right, so we have a way of resetting the buffer. I'm so glad that memset just brought us out of this. I was thinking that we would have to respect the boundaries of memory, and I was like thinking of having this auxiliary function that would do segments of memsets on the different segments of memory. And I would have to look at the boundaries and do the right thing. And I would introduce an off by one mistake and would debug that for 5 hours. Memset not caring about boundaries just makes me so happy. Everything is so much easier that way. All right, so we have a way of resetting this circular buffer. So now all we got to do is use this. So perhaps it would be better if we also had a waveform reset function that would just call the reset on the circular buffer, right? Because we have two circular buffers. So I think it would be nice to have these auxiliary functions, auxiliary function for convenience. So waveform reset of waveform, and this will be, we'll need a couple local variables for this two places in memory. And then we get a hold of them by doing these lines. And then, I know we don't necessarily need to do this because we are only going to use the variable once, but I think that having this kind of style and consistency is nice. So I'll do it the long form. So we'll have these two variables, and we will call circular buffer reset. Just like that. Then we need to call this function when the time comes. So from here, if the JFX is running, I collect samples. And if the sample reset, I will reset all the waveforms. So I will do this whole thing. Hello, Aaron. How's it going? It's nice to see you here. So Bo has been in contact, and it seems like you are up to joining us on the channel and talking about, I guess, basic and introductory stuff, but it will be fun. At least I will learn a lot, so I will have a lot of fun. So I'm looking forward to that. And what's the best way to get in touch? Do you prefer email? Do you prefer chat in some kind of form? Do you prefer... Oh, all right. That's very nice of you. Yeah. So I was thinking... So the reason why I got interested in this in the first place is, I think I can find your email online, right? So I will write to you directly. But I was interested in this because I was watching John Tidy from the REAPER blog on a stream a couple weeks ago, I guess 1 month ago at this point. And he was doing this kit from DIY recording equipment. It is one of those microphone activators or microphone boosters or cloud lifters, because people are using the brand name for the product these times. And it's the simplest circuit, but it is kind of a nice way to get your feet wet in electronics. And it sounds like a lot of fun. So I thought, well, I guess I just got one of those. And then I realized that the shipping and the taxes to get this to Portugal were more expensive than the kit. I was like, yeah, it doesn't really make a lot of sense to buy from them, because it would be, most of my money would not even be supporting the people behind DIY recording equipment. So I thought, okay, what if I just source the parts myself? It's a relatively straightforward project. I should be able to do that. And then I learned that it's not so easy to get a hold of one particular component. And then it got me, I guess, yes, it's kind of sad that I cannot get that component, but I think it was also kind of good because I then started thinking, okay, so how can I replace this? What kind of components do I have available here in Portugal, and what would replace this well? And then I started learning about dual op amps and matching transistors and blah, blah, blah. So I learned more from not being able to have the kit that would teach me about electronics. I don't know. I guess it's just that I'm learning different things. But I still have no experience actually building the circuit, so I cannot say that I learned a lot. But then it got me thinking about, okay, so how would one go about this? How would one know how to replace a component in a circuit? Or is that even feasible? Can you just replace a component? Would you have to adapt the rest of the circuit for this to make sense? And then I started having more questions than answers, like reading schematics and being like, okay, but doesn't tell me what kind of capacitor this is. Is this electrolytic? Is this ceramic? How do I figure this out? And then I'm just like, I think I need some specialist help. So I think that what we could do is perhaps go over a circuit, not necessarily this mic booster, because to be honest, I don't have real use for this. My microphone preamp is more than capable of driving all my microphones, even the dynamic ones. So I don't really care about the mic booster. I think we could just come up with a circuit that we think would be fun. Perhaps it's a mic booster, perhaps it's some kind of filter, perhaps it's a compressor, or perhaps it's anything else. And then we would talk about how it works. You know what I mean? All these kits, they teach you how to solder things in the right place, and they give you an intuition as to what the components are doing, but they don't go in depth into how the design came to be in the first place. And for me, that's the most interesting part, actually. And that's mostly hidden from you because they don't have tutorials on how they designed the thing. They have tutorials on how to build the kit. So I was thinking we could go over one of these circuits and understand how they work and perhaps simulate them on something like Spice. I was playing around with Spice and running audio through circuits to make that happen in the stream if that's something that you would be interested in helping me with. And of course, it would be nice to actually get the components and build something. Oh, yeah, awesome. So if you're interested in that, what I like about that circuit is that it explores some things that I don't fully understand. I was talking about this a couple minutes before you joined us. I don't really understand how phantom power goes through the wire, and the thing about the mic booster circuit is that it is powered by phantom power. It's an inline preamp. So I would really need to learn about how it's a duplex thing in the wire that twists my brain, right? Because the output is sending phantom power, and the output, I mean the output from the mic booster. You connect the microphone into the mic booster, so mic in, and then the out of the mic booster goes to the next part, or I guess the preamp. So the preamp is sending phantom power. The output is sending phantom power. But through the same wires, the audio is going through. So I guess there is DC coming in and there is AC going out because the mic signal is AC. So it's kind of modulating the DC signal. I don't know. It twists my brain in so many ways. I want to learn these things. So the mic booster does have some things that I think are interesting. And of course, I am Googling and I am reading and I'm watching videos and I'm learning more and more. But it would be great to have someone as knowledgeable as you to talk about this. And perhaps I will even be able to source the materials to actually build one of these. That would be great. Yeah. I was actually, I was 10 minutes late to start this stream. And the reason was I was at an electronics store for the first time at this particular store. It's kind of far from home, so I had to bike there, and that took a couple hours. And I just wanted to see what they had. It seems like they have these boxes with like 100 capacitors, 100 I don't know, transistors, that sort of thing. And I was thinking of just buying them, but I don't know. Is this the best way of sourcing things, or should I just have one project that I want to build and then I go and ask, I want one resistor, I want one capacitor, and then I bring those home? I don't know. How do people go about this when they're getting into the hobby, when they're getting into this this journey of learning about electronics? Do they buy a lot of components that they will never use, or do they just buy specific things and then anytime they want to tweak something, they have to go to the store again? I don't know. So many questions. We'll have a lot to talk about. Yeah, I will send you an email and we'll make this happen. Looking forward to it. Also, you are great with vintage circuits. And Dale and Justin are coding soft synthesizers. Yes, Justin Johnson, by the way, for people who don't know, of REAPER fame. Yeah, and at some point we will have Justin Johnson again on the stream to talk about his synthesizer, a work in progress. I'm looking forward to that as well. I'm trying to get my finger in many pies here. All right, let's get back to this. I am resetting the circular buffer when we have just woken up from having been bypassed. So this is the audio thread. When we have been bypassed and we are just waking up, we should reset the circular buffer. Let's see this in action. I'll start by commenting this out, and we'll see how the plugin behaves right now. So right now, I bypass the plugin, and I come back, and the things that were there before are still there. Now I will bring in this code. And now I will bypass the plugin. And when I come back, it has been erased. Great, that worked. Now let's think about the other case where I go to another plugin or I just close the window, right? This makes the plugin stop collecting samples, right? Because we have a check here. If the JSFX is not running, we are not collecting samples, we are saving that CPU. I really like that we are doing this, that we are saving the CPU, and I feel like this is the right thing to do. The sad part is that unless you know about this, and I guess I perhaps will talk about it when I document and make videos about my plugins, but if you don't know about this, you will open the plugin, you will see its CPU use, and that will be your impression of the plugin. So I expect that there will be plugins we will develop that will do a lot of work just for the user interface. So I'm thinking about building a compressor, for instance, and we will have drawings of the waveforms of the audio coming in as well as the audio going out, superimposed, very, I guess, Pro C2-like. And at this point, even ReLimit has this kind of display. So anyway, so I was thinking of having these two as well as a gain reduction curve. ReLimit also has that. So plenty of user interface things that will shut off as soon as the user interface is not showing. But the sad part is that most people will not close the user interface. They will not go to like REAPER, which is kind of a free plugin. So if you add it to a chain, it will not add any CPU use for the most part. So they will never open a different plugin to see what the CPU use is like when the plugin is not showing its user interface. People will judge the performance of a plugin when it's open, which is the worst case scenario, of course, because it has to render the user interface. But for the most part, when you have 1,000 plugins running in your mix, you don't have their user interfaces open. And if we do something very, very efficient, but then we have to do all this extra work for the user interface, people will judge us on our worst. It is what it is. But I think we are doing the right thing. And I think that we are quite unique in doing that. I don't know any other plugin that does this. Perhaps it's a trend and every plugin does it, but none of the ones I read. Like we did a dramatic reading of the oscilloscope from Caucus, and they don't do that. And judging by some experiments we did with other plugins that have this kind of scrolling displays, they don't do that either. It is going to be fun. Right, so when the audio thread was bypassed and gets back, we reset. But also, when the user interface was when the user interface was closed and reopened, it needs to reset, and it's not. See, I will do another demonstration of this, okay? So I will just do a click. So now we are no longer collecting samples, so that click should just go away. It should be erased, but there it is, right? So we're not resetting when we should. Would it work? I was thinking, would it work for us to just reset if the JSFX is not running? But then we would be resetting over and over. And I don't want to do that. I don't want to be resetting over and over. So I guess I could have something similar to this over here. Right, because the JSFX block knows when it has just woken up. But I am nervous about resetting from the JSFX block. I don't think it would lead to any issue, any practical issue. But I do like the notion that the audio thread writes, so pushes, resets, all the writing operations on the waveform circular buffer are done from the audio thread. The JSFX block purely reads, never writes. So I like that notion. So I think I will try to shoehorn something in here. I can try something that I don't think will work, but perhaps it will. So let's give it a try. So what I can do is, if the sample has, if we have just woken up from having been bypassed, or if we have just woken up from not displaying the user interface and now start displaying it again, I will do a reset. The reason why I'm not sure this is going to work is that perhaps the JSFX block will just run, the reset will be true, and the sample block will not have a chance to run. So in that case, this will never be true and we never reset. Now, I don't think that's possible though, because this runs at a much higher rate than this. It runs a lot more frequently. So we should have a chance to have this be true. In fact, I think that we would probably do this a couple hundred times, but that's okay, right? We're just resetting the thing a couple hundred times. It should be fine. It's better than not resetting it at all. And perhaps it will slow things down ever so slightly when the plugin is starting, it's firing up the user interface, as the sample block will be doing our work. Let's hope that this is okay. So now the test is I click, I go to another plugin, I come back, and it has been reset. And I think I saw a little glitch, so perhaps that was the resetting happening too many times. Let's see. Oh, I should be talking because I want the little squiggly forms to be going. So yeah, okay, I go out and then I come back and yeah, it resets. It also seems to reset when I do the square root, which it was not doing before. And that is surprising to me. Let's take this out for a moment and bring the plugin in. So this plugin is still running the code with this thing here. And this plugin is running without that snippet. So if I change here to square root, it does it in place. And this does not do it in place, it resets. If I change the duration, it does not reset. If I change the orientation, it resets. But this one, if I change the orientation, it does not reset. If I change the color, this one does not reset. But if I change the color, this resets. Isn't that something? It seems like what happens is, when I change one of these sliders, not this one, not real sliders, so to speak, but when I change these drop downs, this is behavior, by the way, that we have noticed before, and I have not really understood or explored this idea, but it seems like when you change a slider, perhaps there is a lag on the user interface. Perhaps because of resetting the slider triggers the slider block, and then all of this work has to happen, and then 10 or more frames pass by, and then it resets. I don't know. So let's bring in this code again, and let's get to the bottom of this, because I'm not sure I like that. I think I would rather have the sliders not reset. So one thing that could be happening is this challenge and response doesn't have enough time. When you change a slider, too much work happens and more than 10 frames are dropped. So let's check this by having a larger number. So now I have a large number in there, and if I change, yeah, okay, if I change this, now it is not resetting. But if I go to another plugin and then wait a little bit, more audio will come through, but not through the plugin because it's checking that it is not displaying the user interface. When I go back, it resets. All right, so this is the behavior that I actually want. Sliders don't reset, but going back and in again resets. So 10 is too small, 100 is too large. We'll go with 50 and see if that works. And this is very conditional on my machine because it seems to have to do with race conditions and performance. So maybe on someone else's machine that is, I guess, slower, the little drop-down menu will reset things. But I will just take that. Okay, I will go out, back in. Oh, it's not resetting. Oh, maybe I just didn't spend enough time out of the plugin. Yeah, that was that. So 50 is still a large number because I am able to go out of the plugin and back in, and it doesn't reset. Now, this is not the end of the world because everyone sees this consistently. So the audio thread will still be running, collecting samples. It will be as if we have never gone out of the plugin. And maybe that's a good thing because you want to be able to go back and in real quick and still see stuff. But let's see where this breaks down. We know that 10 is too small. Let's try 20. Okay, that resets, but we should be looking at this actually. Okay, that works. So 20 seems to be a good value, and I will try the going out and back in real quick. And yeah, it's still there. But if I go out, wait a little bit, come back, I'm fine. I'll take it. 20 will be our number. 10 was too small, but 20 seems okay. And I guess we are about 1 second here because we are running at 30 frames per second. That's our refresh rate. And we are about waiting for about 1 second. You know what I could do? I could have this in terms of the refresh rate. I'll just have this. I could have something like half of the refresh rate. Yeah, but this is computation that happens on every drawing of the user interface. So I will not do any more divisions and whatnot just for this silly little thing. I think that 20 will be okay. And if the thing resets when you're changing sliders, yeah, I'll just take it. It's okay. It's what the plugin does when it does that. But I just want to know what is the magic number. Is 15 okay? Let's have a second. So will it reset? It doesn't reset. If I go out and back in, it resets. Okay, so I think we found our value. 15 seems to be my value because it goes out and back in, and if I'm super fast about it, it didn't reset there once. But yeah, see, it didn't reset this time. But if I'm just a bit more hesitant, then it resets. Okay, I'll take it. 15 is my number. That was simpler than I was expecting. I thought that this was not going to work. I really thought that this was not going to work and that I would have to look at the clock to fix it. Because then at this point I would need to check from the sample block if the sample block was not running. Anyway, I just had a different idea. I'm so glad that it worked. And it seems like 15 is a good number. So now we have used both resets, in fact, in a single place. Over here, sample reset or JFX reset, we have used both of them. Okay. For my last trick today, what happens if both the audio thread and the user interface are bypassed? Let's reason about what should happen and then test. What should happen? If they're both bypassed, we should reset. But if they're both bypassed, there will be no one to tell us that. Hang on. Let me explain why I think that this case can be troublesome, okay? So I think that the case where both the plugin is bypassed and the user interface is closed, I think that that can be troublesome because we have this challenge and response going on, right? One challenges and the other answers the challenge. But the problem is if they're both bypassed, no one is challenging. So we may not be able to detect that we have been sleeping. So we may not be able to detect that we have been just woken up. And in that case, we may not reset as we should. But let's think for a moment how we get into this edge case to begin with. Because if you just bypass, then the user interface is running. Or perhaps not, because you don't have to bypass from there. You can bypass from here. So let's see. I have something going on. I will close this. Well, that's already bypassing the user interface, isn't it? And then I could bypass from here, but that's besides the point because we're already bypassing the user interface. So I guess the issue could only arise if you could, perhaps with a custom action or something, bypass and close the user interface simultaneously. Then both threads would stop working at once and no one would be able to tell that the other needs to wake up or that the other has just woken up. But I don't even know how to do this. I guess I would need to look for a custom action or create a custom action. I would need to look for an action that bypasses a plugin and closes its user interface, and I would need to have a custom action that does both at once, and then I would need to... who cares? This is such an edge case anyway. Either you're going to bypass and then close the user interface, or you are going to close the user interface and bypass. And in either case, the other thread will be awake to tell that we have been reset. And then this will do the right thing, I hope. So case closed. What happens if both the audio thread and the user interface are bypassed? Well, it doesn't matter, because in this case, the user interface is bypassed. I just bypassed the audio thread, but for a long time, the thing has been reset already. So if I just open the user interface, it is going to be reset. So as soon as I do this, new audio comes in. So yeah, it just works. Who cares? It is not a big deal. Great. So don't draw when the effect is bypassed, not receiving samples. Check, we are not drawing. We set the circular buffer when the sample is waking up from having been bypassed. We set the circular buffer when the sample has been just, well, yeah, okay. And what happens if both the audio thread and the user interface is bypassed, or are bypassed? Nothing happens, don't worry about it. Seems like this session was a lot of talking and very little writing, but I do think that sometimes in programming there is more reasoning than actually doing the monkey thing. Take that as you wish. All right, so that's it for today. I am wrapping up. Tomorrow I will be back and we are going to keep pushing forward on this plugin. We are almost there. There is very little that I still want to do, but there are some things. So we'll go over these things. Perhaps rectified peaks. I don't know. Maybe stroke. Maybe these things. Maybe zoom. We'll do some of these. One of these. Or maybe all of these. All right, let me bring back the plugin because it's so beautiful. Here is our plugin. I want to have this on the screen while I say my last goodbyes. So thank you, Bo and Aaron and Tail, for being here on the chat. Thanks for watching this, everyone else who is not on the chat. Thanks for supporting me on Patreon, Bitcoin, PayPal, all those places. I look forward to seeing you tomorrow for more of this. So take care, and I see you tomorrow. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.